Hi everyone, it's Shadaj again, and today we'll be solving problem number 19. Here we have the problem. The idea of this problem is we need to find how many Sundays are on the first of the month between 1st January 1901 to 31st December 2000. So there are many ways to do this. One way would be to use algorithms such as Gauss's method, which lets you get the day of the week based on the date, which is the day, month, and year. But let's say we didn't have access to Wikipedia and all we have is Project Euler. We're going to create a solution that just uses the information that Project Euler gives us. So first we can try a statistical approach, assuming that there's equal distribution. So let me create a new worksheet in which we'll do our math. And I'm going to name this Euler 19 work. Okay, so what we know is there are 12 months in a year, and we know that 1 out of 7 days on average will be a Sunday. So you divide by 7. And so this is on average how many Sundays on the first day of the month there will be in a year. So now we multiply by the number of years, which is 100, and we get 171.42 ... So the answer we actually are looking for is 171. So this gives us a pretty close approach. But there can be issues when we're working with things like leap years and having things right on the edge, including and not including, and rounding. So we're going to be creating an algorithm in which we go iteratively over every single first of the month between the start and end date. So I already have 2 methods ready for us to use. I have days and month, which is just a list of how many days are in each month, and also is leap year, which we're going to be using to see if we need to jump extra. So basically the idea is we're going to start with information of what's our current day, month, and year, and the day is day of the week. And what we're going to do is to calculate our new day of the week, we're going to add the number of days in the current month, which is basically jumping us to the first of the next month. So when for example, January, we know that the 1st of January in 1901 is Tuesday. So then we're going to add 31 more days to jump to the 1st of February. And we keep on doing that. So first what we need to do is we need to create a way to get the days in the month, including leap years. So we're going to create a method days in month, which takes the month and the year. And this is going to give us an integer. So what we want to do is if the month is February, and since we're 0 based for month, February is 1, and it is a leap year, then we want to return 28 plus 1, 29, because there's 1 extra day. Otherwise, we just get the days in month for the month that was given to us, because you don't have to apply anything special. Now let's create our algorithm. So we're going to have def count Sundays, and we're going to have the current month, the current year, the current day, which we'll call day of week for clarity, and the count of how many Sundays we've counted so far. And this is going to return it. So first of all, if we are, and one last thing we need to include is when do we stop? So that's going to be our last argument, which is end year. So if the current year is at the end year, then we just return the count we have so far. But otherwise, if we want to continue counting, we're going to calculate new values for month, year, day of week, and count. So first for our new month. we just add 1 to the current month and watch out for overflow by doing modulo 12. And after that, new year, what we're going to do is we're going to do the current year and add 1 if our month is, or if our older month represented December. So you're going to, and since it's 0-based indexing, we add 1 to the month and divide by 12 to do that. And the new day of week is going to be, we get the current day of the week. We add how many days are in the current month to jump to the first of the next month. So we put month and our year. And then to account for overflow, we're just going to do modulo 7. So that'll give us a value between 0 and 6. And lastly, our new count is going to be if, so our day of week system is 0 Sunday, 1 is Monday, etc. So if our day of the week is 0, which means it's a Sunday, then we add 1 to our count, else we keep the count the same. And now we just recursively call count Sundays with our new month, new year, new day of week, and our new count, new count, and the end year. Spelling mistake. Okay. Now let's call this method to get our answer. So we're going to be println count Sundays. So our starting month is January, so that's 0. Our starting year is 1901. Our starting day of week, since we know that the 1st of January in 1900 was a Monday, we know that the 1st of January in 1901 is a Tuesday. And since 0 is Sunday, Tuesday must be 2. Our count is 0. And our end year is 2001, because we want to include all of 2000. So we want to stop when we get to 2001. Now we can run Euler 19. And we get our answer, 171. I'll see you next time when we solve problem number 20. I'll see you there. Bye.